Kia ora all, here is the video going through the TGC Level 2 Derived Grade Chemistry exam for 2024, and this is the chemical reactivity paper. First question is about rates. So in 3 different experiments, 2 grams of magnesium is added to 5 mils of hydrochloric acid. So the amount of the reactants is not changing. The nature of the reactants was varied as follows. So we've got 3 test tubes, 1, 2 and 3. In test tubes 1 and 2, they are both powdered magnesium with different concentrations of hydrochloric acid. And in test tube 3, we have ribbon, and it's got 1 mole per litre. So test tubes 1 and 3 have the same conc but different surface area. Test tubes 1 and 2 have the same surface area but different concentrations. And here is the equation for the reaction with the reactants and the products. So would we expect the reaction in test tube 1 or 2 to have the higher? This is our concentration comparison, so obviously this would have a higher reaction than 1. So we're going to launch straight into it. So test tube 2 has a higher concentration of reactants, even reactant particles. And notice I've said higher, so I've got to say then what? Than test tube 1. Therefore, we'll have a faster rate of reaction. Whoops, we'll have faster reaction rate. Now we need to give a reason. In test tube 2, there are more, now let's be specific here, what are there more of? Hydrochloric acid. There are more HCl particles per volume. You can put per mil or per litre. Therefore, there are more collisions between reactant particles likely to occur. And therefore a higher frequency of successful or effective collisions per second than in test tube 1. Therefore, have I referred to particles? Have I referred to collision theory? So I've talked about collisions between reactant particles. Therefore, the products MgCl2 and H2 will be produced, out of the way cat, more quickly than in test tube 1. No, away you go. Explain in this part whether you would expect the reaction in test tube 1 or test tube 3 to have the higher reaction rate. So 1 and 3 is where we've got the same concentration, but we've got the different surface areas. So the one that's going to be quicker is test tube 1, as it's got the larger surface area than test tube 3. Okay, test tube 1 would have the higher reaction rate. Both 1 and 3 have the same conc, but in test tube 1 the magnesium is powdered, increasing its surface area. Now I'm abbreviating a lot just because I don't want these videos to be too long. You need to write all your abbreviations out in full the first time you use them, but you can abbreviate after that. Right, so increasing its surface area, and increased surface area means more reactant, and in this case the reactant is Mg. Mg particles are exposed, that's our key word here, and available to react. Collisions between Mg and HCl are therefore more likely to occur. and this increases the frequency of successful product making collisions. Therefore, test tube 1 has a faster reaction rate than test tube 3. Faster reaction rate than test tube 3. Did we have to do anything else? Refer to particles? No. The only other thing that they possibly could ask really here is how much of the product is produced, but they have not asked that. Okay, going on to part 3. The rate of the reaction at various temperatures can be determined by measuring the volume of gas produced. And this shows how they do it. Question says compare the rate of reaction when the two reactants are mixed at 2 different temperatures, all other conditions kept the same. Okay, so this one actually has a graph, and so I probably will comment on where that graph finishes. And temperature's our tricky one. There are 2 effects. This was a common issue we found in our topic test. Okay, so at 40 degrees, reactant particles, so Mg and HCl, have a greater kinetic energy. This means, 1, particles move faster than 20 degrees. Oops, wrong way. Which means collisions are more likely. Collisions are more likely to occur. That's the first thing. Faster moving, more collisions. And 2, as the reactant particles have more EK, more of the particles or more of the collisions have energy greater than the activation energy. Therefore, more of the collisions are successful, which a successful collision is a product making collision. Okay, therefore, as the particles are both more likely to collide and more likely to have a successful collision, the reaction rate increases due to more successful collisions per second. Okay, is there any more space over the page? No. So if I was worried, I would just probably put up here same amount of products produced as same amount of reactants. There we go, just to add that in, just in case. Last question in part 1 is B. Here's our clue about what this is about. The catalytic converter, blah, 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 blah. That's all just information, but really what we need to know is what are we talking about? The role of the metals in this reaction, and obviously these metals are acting as a catalyst. Right, it's combustion up here, so we should know that combustion is exothermic because the purpose of combustion is to burn stuff to release the energy. So we're looking at a reaction that profile looks like this, and we need to do without catalyst and with catalysts. So like everything, if there is a diagram to do, I would do that first so that you can use it to make sure that your words are targeted to the answer. So the metals act as a catalyst. A catalyst provides an alternative path, see below, below, with a lower activation energy. So we don't want to say that the catalyst lowers the activation energy, because it doesn't. It provides something different, a different way of doing it that has a lower activation energy. So that's important. And therefore, more particles have sufficient energy to overcome the activation barrier and successfully collide to form products. Therefore, there is a higher frequency of effective collisions. So that's more collisions per second. And therefore the catalyst gives a faster reaction. It does say a labelled energy diagram, so I'm going to go put my EA and my EA2 in, and this is my reactants, which are carbon monoxide plus oxygen, and these are my products, which are carbon dioxide, and here is my delta H. It does say labelled energy diagram. I don't really think they want all this, but it's not going to hurt to put that information in. And that's the end of question 1.